For our last hour today, we're going to totally shift gears. And we're going to talk about powers and roots and applications. And we've talked about this a little bit, that powers and roots are just like addition and subtraction, where they're the same operation, just one's going forward and one's going in reverse. What I mean by that is, somebody pick a number between 5 and 10. 7, okay? Somebody pick another number between 2 and 5. 3? Okay. Sorry, you're outvoted. So 7 plus 3 equals 10. If I want to go from that 10 back to 7, what do? I subtract 3. So adding 3 and subtracting 3 get us right back to where we started. The same thing occurs with multiplication and division. If I do 7 times 3, I get 21. And if I want to take that 21 and get back to 7, what do? Divide by 3. So multiplying by 3 and dividing by 3 get us right back to where we started. If I have 7 squared, what do I get? 49. If I want to take that 49 and get back to 7, what do? Square root. The square root of 49 is asking what number squared equals 49? Well, it's 7 squared. So if I have 5 to the power of 3 equals 5 times 5 is 25 times another 5 is 125. If I want to get from that 125 back to 5, what do? It's called a cubed root. It reverses the power of 3. Now for this class, we're not going to do cubed roots. We're not going to do anything higher than a square root. But I want you to be aware, a lot of people aren't aware that there are roots other than just square roots. A cubed root goes with the power of 3. A fourth root would go with the power of 4, and so on. What is 6 squared? 36. Okay. What is negative 6 squared? Careful. It's 36. And I've warned you before, you do have to be careful on your calculator. If I do this, negative 36, or negative 6 squared, my calculator is going to try to tell me it's negative 36. It should be a positive. The reason is, the calculator does a strict order of operations. Squared happens before a negative. An exponent happens before a negative. It's squaring the 6 and then putting the negative on it. Many of our calculators, you have to put the negative number in parentheses to square it. So what that means is the square root of 36 is 6 or perfect, has 2 answers to it. Now the other side of that is square root of negative 25. Well, what happens if I put that in the calculator, square root of negative 25? It says error. Not going to do it, right? Yeah, there's no number that we can multiply by itself that gives us a negative, because positive times a positive has to be positive. Negative times a negative has to be positive. So any number squared will always be positive. Therefore, we cannot take the square root of a negative number. Now, I tell you that kind of tongue-in-cheek because if you were to get into college algebra and the abstract algebra section of it, they actually will look at taking the square root of a negative number, and they call it imaginary numbers that they've made up to work those out. We're not going to get into those. if we had something like 3/4 squared, how did we do that? Well, remember, there's two ways to look at it. That's 3/4 times 3/4. But to do it out, it's just going to be 3 times 3 is 9, and 4 times 4 is 16. 3/4 squared can be thought of as just 3 squared over 4 squared. You square the numerator, square the denominator. And that's true of any power. If I have 3/5 to the power of 6, I can make that 3 to the power of 6 over 5 to the power of 6. 3 to the power of 6 is 729. 5 to the power of 6 is 15,625. And that's it. 3/5 to the power of 6 is 729 over 15,625. Any questions? Some of your calculators will do that as a fraction. If you put it in parentheses and put 3, parentheses, 3 ABC5, close parentheses, and then do the caret, the power to 6. Some of your calculators will display that. Some will not, because it can't. Some calculators can't display 5 digits in the denominator. So anyway, the main reason for our review of powers and roots here is because we're going to get back to our angles and rays, and we're going to talk about triangles. A triangle is a figure that has 3 sides. What we're going to look at today is we're going to focus on a special triangle called a right triangle. A right triangle is a triangle that has one right angle in it. Now, it can only have one right angle. It can never have more than one, because if it had 2 right angles, well, if I had a right angle here and here, those 2 sides would never come back together, would they? They would actually have to be parallel. Because these two right angles are supplement. 90 and 90 makes 180. They're supplementary. And those 2 angles are supplementary. That has to be parallel lines. So you can't have 2 right angles. In fact, if you have a right angle, the other 2 angles will always be acute. They won't necessarily be equal, but they will always be acute. When we are looking at a right triangle, then, there's one rule about triangles that's not commonly known, but an extremely powerful rule, and that is the largest side is always across from, or what they call opposite, the largest angle. Well, if one angle is a right angle, we said the other 2 have to be acute, so the other 2 have to be smaller angles, which means the largest side has to be this side over here. That has to be the largest side. That'll be the side that is across from or opposite of the right angle. And that has a special name called the hypotenuse. The other 2 sides are called legs. Now, if we were into trigonometry, we would talk about adjacent leg and opposite leg, depending on what angle we're looking at. All we need to know for right now is those are the legs. One way that I remember it is the legs form the L. L for legs. Those are the two sides that touch the right angle. Those are the two sides that make the right angle. So when we are labeling a triangle, we label the sides with small letters, and we're typically going to use A, B, and C. So we would label the legs sides A and B. And the hypotenuse almost always gets labeled side C. Depending on the textbook, this next thing is called either the Pythagorean Theorem or the Pythagorean Rule. It technically is a theorem because it can be proven. And what it states is, if you take the length of one leg and square it, and the length of the other leg and square it, if you add them together, you will get the length of the hypotenuse squared. So things that we can use this for, we can test to see if a triangle is right. So let's try that. Let's say that this side of the triangle here is 12 inches. This side over here is 25 inches. And this side up here is 27 inches. It's always easier to pick out the potential hypotenuse. Which side would I want to use as side C here? Why? It's the largest side. The hypotenuse would always be the largest side. So here, if this is a right triangle, 27 would have to be the hypotenuse. So the other ones would have to be sides A and B. So that means 12 squared plus 25 squared would have to equal 27 squared. Now you notice I didn't put an equal sign in there yet because I don't know if they're equal. What is 12 squared? 144. 25 squared? 625. 27 squared? 729. If I add these together over here, 144 and 625, I get 769. This is not a right triangle, is it? So it's not going to be a right triangle. Let's give you another one to try. Let's say this here is 8 feet, 15 feet, and 17 feet. Which side am I going to pick to be side C? 17. So the other ones are A and B. So let's test it. 8 squared plus 15 squared. And I'm going to compare that to 17 squared. What is 8 squared? 64. Good. 64. 15 squared? 225. That adds up to 289. What is 17 squared? 289. So that is a right triangle. Where does my right angle go? Here we go. Between the top left corner. Between A and B. Between the two legs. The two shorter sides. Perfect. The other thing the Pythagorean theorem can be used for is to find a missing side if we know it's a right triangle. So if we already know it's a right triangle, we can use it to find a missing side. for example, if I tell you that that's a right angle, and this is 7 inches and 24 inches, and we'll call that x. How would I find x?
7 squared plus 24 squared.
You got it. 7 squared plus 24 squared equals x squared. 7 and 24 are the legs, so I'm going to call them A and B. X is the hypotenuse, so I'll call that C. What do I do from there? Well, what's 7 squared? 49. 24 squared? 576. 49 and 576 is 625 equals x squared. Now what do we have to do from there? We have to square root it. Because it's x squared, we want to know what x is. Square root of 625 is 25. So that hypotenuse is 25 inches. Pretend that looks like a right angle. I did a horrible job there, but so here, how would I find x?
10 squared plus x squared equals 26.
Okay, good job. We see here that x is one of the legs. So yes, 10 squared plus x squared equals 26 squared. 10 squared is 100 plus x squared. 26 squared is 676. Then what? Subtract the 100. X squared equals 576, and then got to square root it. So x equals 24. Of course, the units were feet, so that's going to be feet as well. Make sense? Why do we care? Well, applications that this gets used for. We'll look at some practical ones and maybe some silly ones just for fun. First, I'm going to look at building a house. Bless you. And the house I'm going to build is going to be 30 feet by 40 feet. And when I lay out the foundation of this house, I want to make sure that these corners are square. So what I'm going to do is I'm going to get one side laid out, then the other side, a second side laid out. Then I'm going to measure from corner to corner to see if it's square. What length would that have to be for this to be square? Well, the 30 and the 40 are the legs. That diagonal would be the hypotenuse, would be C. So it would be 30 squared plus 40 squared equals C squared. Figure out for me in your notes what C has to be. 30 squared is 900. 40 squared is 1600. That adds up to 2500 equals C squared. And when you square root that, C is 50. So it has to be 50 feet. On your calculator, most of you do have to hit second to square root. So the easiest way to do it is to do this. You hit second, square root. Then many of your calculators will put an open parentheses there. Like that. It looks like that. The square root symbol is open parentheses. So you'll type in the 30, hit x squared, plus 40, hit x squared, and then you'll close the parentheses. And when you hit equal, it'll actually just do the 50, just like that.
I was just hitting the key above it
Okay.
by accident.
Well, we're going to look at Rob here in the classroom. That's what you get for sitting by the teacher. You get picked on all the time, right? And we're actually going to take a look back at Rob's teenage years. That's always good news, right?
Yeah.
And we're going to look at a day Rob snuck out late at night or came home after curfew. And he's going to climb back in his window using a ladder. He knows that his dad's got a ladder sitting over at a woodshed. He's just going to swipe that ladder and he's going to put it up and climb in his window. He discovers that the ladder is 12 feet long. Because of stuff next to the house, that ladder cannot get closer to the house than 7 feet. For this to work, the ladder has to get him within 4 feet of the window. If it's not within 4 feet, he can't grab onto the window and climb in. So the question is, what is the maximum window height? So what I want you to find first, of course, is this height here, that when the ladder leans up against the house and the bottom is 7 feet away, how tall is that going to be? And then adding 4 feet to it would give you the maximum window height. So I want you to try that in your notes quick. So when I set this up, sides A and B are going to be the 7 and the X. The 12 will be the hypotenuse. The right angle, even though it's not drawn in there, has to be there. We hope that the house is square with the ground, if the ground is flat and level, right? So that gives us A squared, well, actually 7 squared, plus X squared has to equal 12 squared. So 7 squared is 49, plus X squared equals 12 squared is 144. We subtract the 49. x squared equals 95, and we square root. So x equals 9 point what? 75, yep. So the maximum height of that window would be 13.75 feet. We'd add 4 to that. Now again, you can do this all in your calculator at one step. What you would do is this. You'd hit your square root key, and it would give you that open parentheses. You just have to type it in backwards. You have the hypotenuse, the 12. So you're going to do 12 squared minus the one leg you're given, which is 7 squared. And close the parentheses. Gives you the 9.75. Any questions? Okay. I have an extra credit question that goes along with this topic. And it's going to come up in just a second. Let's say that you are camping. And here's your tent. And from your tent, you decide to go hiking. You hike 7 miles due south. And then you turn and you hike 24 miles due east. How far are you away from camp? If you were to go straight back cross country. How do we find that length?
7 squared plus 24 squared.
You got it. That's going to be our hypotenuse. So yeah, 7 squared plus 24 squared equals, I'll just call that C for now, C squared. And we would go ahead and we could work that out. Now I'm just going to put it in the calculator. Am I adding or subtracting here? I have both legs, so I am adding. So second square. What's that?
What happened to the 5 miles?
It was 7. 7 miles due south, 24 miles due east.
Oh, that's south. I thought it was a 5
Nope.
miles, not south.
That's an S, sorry.
It looks like 5 miles, sorry. Okay.
I'll try to make it look more like an S. There you go. So yes, we are adding because we have the 2 legs. So it's 7, the square root, and then in our parentheses, 7 squared plus 24 squared. You guys would have to close your parentheses and hit equals. We get 25 is that distance. So it'd be 25 miles to go straight back to camp. If you remember, area is length times width. We discussed that before, right? So if I have a square here, and I know this is a square because I'm going to mark the sides like that. That little hash mark in the sides means that those sides are all the same. If there was like a double hash mark on one of them, that would mean that side is different. But they all have a single hash mark telling me that they're all the same. So if I label the one side 12 inches, how am I going to find the area? Well, I could do 12 times 12, which is 144, and of course that's inches squared, or square inches. But I could just do 12 to the second power, 12 squared. That's where that language of saying that the second power is squared comes from, because it comes from a square. With that in mind, if I give you a square and tell you that its area is 49 square feet, how would I find the length of a side?
Square root of 49.
Perfect. The square root of 49, which is 7. So that side would be 7. What would the units be? Feet. Since that was square feet, this is just feet. Yes. Perfect. Any questions? Okay. I just got to double check to make sure what's in your homework, to make sure I didn't miss anything. In the summer, there's some assignments that double up, so I want to make sure that I don't have to get into the next lesson plan here. No, that's going to be it. So that is all of our new material for the week.
Nice.
So time for your big extra credit question. I will have you email me your answer to this one. I won't let you say it in class. And what will happen is anybody who emails me the correct answer before class tomorrow, this is a 10-point extra credit question. Well, let's get a little more colorful with this one. So let's say you go hunting. And you're going to go bear hunting. From camp, you walk 5 miles due south. And you sit there sit on a stump there for a while. You eat your lunch. What's that?
Holding a stick.
That's a gun.
I thought you were very brave there.
We're hunting.
We're hunting. Yeah. We're hunters, not stupid. Well, we're not going to cross that line. After you eat your lunch, you decide to walk due east, and you walk 12 miles. Due east. At this point,
You're growing a bear now.
shh, don't spoil the surprise. You spot a bear. And you shoot him. You kill him.
Gotta get the blood in there.
Oh, I have to. You have to drag this bear, obviously, back to camp. And you realize that at this point, you're exactly 5 miles away from camp. So your extra credit question, and you have to not only answer the question correctly, but you must explain why
We have to draw
What?
pictures too.
no, you don't have to draw pictures. What color is the bear? Again, you must explain why. And no, you can't say it's red because of its blood. What color was the bear before you shot it?
We're not hunting in like Colorado or Washington or anything. Are we hunting in my backyard?
That I cannot answer. The mathematics of the question will answer that question for you. So like I said, anybody who sends me the correct answer to that and justifies it, You have to give me the reasoning why it has to be that. By tomorrow's class, it's 10 points.
Okay, you know it.
There is a new quiz. I believe this one is quiz 13. That is due tonight at 11:59 p.m. There is a new homework. I believe this one is 14. It is due for tomorrow in class. So I'll give you guys the last 35 minutes here to get started on homework. I realize I loaded you down a little bit with stuff from last Thursday, so you also have test corrections to work on. Before we totally cut it off here, I do want to mention one question off the test that tended to stump people this time around. For those of you that don't have the test, I'll lay out the whole question. It is question number 27 on the test. Number 27 is the swimming pool. And it says the swimming pool is 18 feet by 30 feet. So that would give it a perimeter of 2 times 30 plus 2 times 18, which is 96 feet, if you add that up. So that's the perimeter of the pool. Then the problem says we are going to build a deck around the pool. It's the same size on each side, all the way around. Same width all the way around. We're going to call this X, right? Now, it really doesn't matter. The way I drew it, it's going to work out a little bit different. There's another way you could do it. But it says the perimeter of the deck is exactly twice the perimeter of the pool. So that means the deck, the perimeter has to be 96 times 2, or 192 feet for its perimeter. So the perimeter, meaning 2 times the length plus 2 times the width. We're going to put 192 in for the perimeter. 2 times the length is the 30 feet here of the pool plus the width of the deck on each side. The way I drew it, you would write it as 30 plus 2x, because there's x on each end of it. You could have just said, we're going to let x be the amount that the deck adds to it. Then you could have just did 30 plus x. You'd end up getting the same result. X would be a different number, but the total result would be the same. Then you're going to add the width, which is going to be 2 times 18 plus x on each side is 2x. So now we're going to multiply the 2 through the parentheses here. 2 times 30. 60. 2 times 2x. That's 4x. We're going to multiply this 2 through the parentheses. 2 times 18. 36. And 2 times 2x. 4x. Now what? 60 and 36 make 96. And 4x and 4x makes 8x. What's next? We do subtract 96. 192 minus 96 is 96. Equals 8x. Divide by 8. So 12 equals x. So what that means is we go back to our picture. This is 12 feet here, 12 feet here, 12 feet here, 12 feet here. So the new width is 12 plus 30 plus 12. Which comes out to be 54 feet. The new width is 12 plus 18 plus 12, which turns out to be 42 feet. Like I said, you could have also done it as just the new width, new length and width. It would have been 30 plus x and 18 plus x. You would get that x is 24, so you just add 24 to each of the length and the width, which is what we did. We added 12 twice. Okay, I will let you guys have, like I said, I'll let you guys have the rest of the class to get started on the quiz or the homework or work on test directions, either one. The network will be up until noon, so I'll be online here for another 50 minutes or so. So if you have any questions, give me a yell.